Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Muhammad Haris Haziq bin Muhammad Suhairi. I'll be presenting my PSM2 presentation, which is the title of my project is Enhancing Mechanical Performance of Pineapple Leaf Fiber Reinforced Composite through Eco-Friendly Surface Treatment. These are the contents of my report. We will cover the problem statement, objective, and the scope of my research beforehand. And we will look into the methodology of my research, and we will focus on the result, discussion, conclusion, and then recommendation. So this is the problem statement. So the problem at the moment, we are using a lot of synthetic and non-renewable materials. So we are looking to further invest into biodegradable and eco-friendly materials, such as using natural fibers instead of synthetic fibers. However, these fibers need to undergo alkaline treatment before they can be used as a composite. However, conventional treatment uses sodium hydroxide, which is now, and this chemical is very toxic when it is disposed. So we are trying to implement a much safer, eco-friendly treatment by using sodium bicarbonate. So these are the objectives of my research. Number one is to compare the effect of alkaline treatment on tensile properties of pineapple leaf fiber. Number two, to evaluate the effectiveness of surface treatment on tensile properties of polyamide composite. And finally, number three is to correlate the effect of surface treatment on the morphological properties of pineapple leaf fiber. This is the scope of my research. The fibers are soaked in a treatment of 5% and 10%, 5 weight percent and 10 weight percent of sodium bicarbonate. There are 4 different treatments. The differential between them is that for the 5% and 10 weight percent, we are adding hot water treatment for 30 minutes before they are soaked with the sodium bicarbonate. And we are also doing the alkaline treatment using now as a comparison. So after the fibers have been treated, we will then use testing methods such as single fiber test, FTIR, and also test them using when they are in the PA11 composite. So this is the methodology of my research. As you can see from the start, we have the fibers in the surface treatment. We have categorized them from using sodium bicarbonate and one with using now. After the surface treatment, we will see the analysis using chemical analysis using FTIR. This is to see if the chemical treatment is effective in removing the waxy lignin and also the impurities from the fiber surface. Next, we have the single fiber test. This is using the universal tensile machine. The fibers are placed in a paper frame and they are pulled to see if the tensile strength and tensile modulus. After that, the composite are fabricated using the pineapple leaf fiber and polyamide 11 or PA11. This is at 200 degrees Celsius using pressure of 7 bar, where the fibers are then where the composite is then cut to be used for factorial testing. Finally, we have morphological analysis using SEM to see the surface of the untreated and the treated fibers. Next, we have the effect of surface treatment on pineapple leaf fiber. This is the FTIR result for the untreated fiber. As you can see, I have highlighted regions where there is lignin, ester, and wax. So these are the FTIR micrographs of the treated fibers. For the lignin, ester, and wax regions, you can see there is a reduction of intensity of the peaks. So this shows that the alkaline treatment is effective in removing these components. So next, we will look into the single fiber test to see if the tensile strength and tensile modulus of this fiber is better than the untreated fibers. So for the single fiber test, we can see that the 5 weight percent of sodium bicarbonate at room temperature has the highest tensile strength compared to the untreated fibers. But when we introduce hot water, we can see a slight reduction in the strength. However, it is still better compared to the untreated fibers. But at 10% of sodium bicarbonate with hot water, that has resulted in the lowest strength compared to all the other results. This shows that alkaline treatment is able to remove all the impurities, and with the removal of these impurities, it can increase the strength of the fiber. However, if we remove too much impurities, it could cause degradation and could lower the structural integrity of the fiber itself. Next, we have the flexural properties of the pineapple leaf fiber PA reinforced composite. So over here we can see that the flexural strength of the untreated fiber is the highest compared to the treated fibers. So theoretically, the untreated fiber is supposed to have the lowest compared to the treated fibers. However, in this research, in my research, this could be due to factors such as air bubbles or fiber migration, where when we fabricated the composites, the fiber and the PA11 sheets are hand laid up using sandwich method. When we press the mold at the heat press, the fibers tend to shift around in the composite, so we will not have a uniform spread of the fiber in the composite itself. So this could cause, maybe when we cut the composite, some parts may have 3% fiber, some part may have 10%, may have 1% fiber, some parts may even not have any fiber in it at all. So this could be the cause of the result that we have here. And also we can I observed that the air bubbles in the composite are also the cause of the result itself, since the bending could be affected, the flexural bending could be affected by these air bubbles in the composite. Next, we have the morphological analysis. Next, we have the morphological analysis of the pineapple leaf fiber. So these are the morphological properties of the fiber surface. As you can see, in the untreated fibers, there are impurities in the fiber surface. From figure B and C, which are 5% and 10% sodium bicarbonate at room temperature, there are still impurities in the fiber. However, we can see that the fiber is slightly cleaner compared to the untreated fibers, and when I handle the fibers, they feel a lot smoother to the touch. Next, we have the 5% of now and 5% and 10% of sodium bicarbonate with hot water. So these morphological from these pictures we can see that the fiber surface is much cleaner and compared to the untreated fibers from before, and also they have a much rougher and jagged surface compared to the untreated fiber. However, when we are handling them, when I am handling them, I could feel that they feel a bit stiff and a lot rougher to the touch compared to the fibers before. So for the conclusion, we can conclude that chemical analysis shows that alkaline treatment is effective in removing impurities and lignin by using sodium bicarbonate. Next, we can see that the tensile properties of single fiber pineapple leaf fiber is able to increase with the usage of alkaline treatment. Next, we can see that the tensile properties of pineapple leaf fiber is at its highest at 212.52 megapascal, using 5% of sodium bicarbonate at room temperature compared to 151.28 megapascal using 5% of now. For the composite, since due to the experimental errors, we could not conclude our data accordingly, but we can see that the shift in the migration of the fibers could affect the results, and also the porosity or air bubbles could lead to different results compared to from previous research. And finally, morphological analysis shows that the alkaline treatment using sodium bicarbonate is capable of removing impurities from the fiber surface, and it also shows similar results compared to sodium hydroxide or now. For my recommendation, for future research, maybe we could evaluate the effect of different fiber loading using different percentage of fiber. For example, using 10 weight percent, 15 weight percent, 20 or 30 weight percent. Next, we could include additional treatments such as silane or acetylene treatment. Since for my research, I'm only using alkaline treatment to see if they can better improve the bonding between the fiber and the polymer matrix. And finally, we could evaluate other forms of the pineapple fiber by using maybe a short fiber or powder to reinforce the composite, since in my research we are using the long fiber. That is all for my presentation. Thank you very much, and Assalamualaikum.